All right, fantastic. So thanks for joining us today, everybody. Like I said earlier, my name is Maxwell Bendis. I'm a representative of the Department of Agriculture within the Pesticides branch. Today, we're here to talk about application preparation and best practices for using pesticides. So at this point, you already know what you're targeting. You already know what you're spraying. You're ready to go, but you got to check certain environmental conditions. You have to check certain conditions about the plant or the pest or the structure that you are applying to, and you need to prepare yourself and your equipment to do your application correctly and accurately. So we're going to get into some of those tips and tricks, some pitfalls you can potentially fall into, and we're going to talk about the process and answer any questions that you guys have for us. So to start, these are some of the learning objectives that we're going to be focusing on today. We're going to cover environmental conditions, and we're also going to talk about how pesticides interact with our environment. We're going to talk about pest life cycles and how to time your application according to those life cycles. We're also going to cover some principles of integrated pest management. I don't know how familiar you all are with that concept, but we're going to be covering some of the basics and talking about how we can apply those concepts in our everyday work life and also at home. And then we're going to get into some math, unfortunately, but pesticides utilize math in order to use them correctly. So we're going to talk about how to calculate your site size and your dilution rate. And then we're also going to cover some types of equipment that you might run into and some different materials that equipment can be made of and certain pitfalls when working with different types of materials. So to start, let's talk about weather conditions. So it's really important when you're using a pesticide to make sure that it's not raining or going to rain within the next 12 hours. If you spray out a pesticide and then it rains, then that rainwater is going to wash all of that pesticide away from your target area. And now you're going to be infecting non-target areas with that pesticide runoff. That's something that we want to avoid, not just because we're spreading this pesticide into areas where we don't want it, but also because that is a label violation. So the label of the pesticide, it says that you pretty much every pesticide that I'm familiar with has some type of rain clause where it says, do not apply if it's raining, do not apply within 12 hours of suspected rain. So if you were to apply while it's raining, that would be a label violation. That is against the law. Wind. It's also really important to check your wind speed. Just like the rain clause, many pesticides will have a clause about acceptable wind conditions for application. Oftentimes, these label rates can be basically, if it's above 15 miles per hour, do not spray. But also, if it's below 2 or 3 miles per hour, also do not spray. So obviously, when the wind speeds are really fast, the wind is blowing really hard. That makes it really difficult for our spray to actually wind up where we want it. The wind is going to take it all over the place. But when there's no wind, what can happen is you can get what's called a temperature inversion. So hot air and cold air kind of swap places. And then that makes the wind go in all sorts of crazy directions in that area. It becomes very difficult to predict. And so that's why we want to avoid those types of situations as well. So the key range that we're looking for wind speeds is actually between 3 and 10 miles per hour. Obviously, you're going to have to make some choices in terms of the actual space and location you're in, if you feel like you can safely spray or not. But if you're within that 3 to 10 mile per hour range, generally, you're going to be okay. You had your hand raised really quickly for a question?
Yes, sir. Is this slide going to be available for everybody?
Yes. So we'll make these slides available for you all. So if you want to take notes, that's great. That's awesome. Also, this whole webinar will be available as a recording on YouTube for you to check later. So not just the slides, but also the conversation that'll be available for everybody. I have a fancy little tool here today. This is called an anemometer, basically a wind meter. So you can hold this up and this will check the wind for you at your actual site. So you can get wind speed ratings online from weather reports. You can go on surf reports, wind finder. There's lots of places to get wind speeds online. But what really matters is the wind speed where you are standing and where you are applying. And especially with the myriad of winds that we have here in Hawaii, you can have different conditions on the ground compared to what those wind reports are telling you. So very, very good idea to ground proof your wind speeds and actually measure them before you apply, especially in the case of labels that do have those wind speed requirements. Because you want to be able to prove to an inspector, if you ever do get inspected, that you were following those label restrictions and that you recorded the actual wind speed on the day. So we'll have this anemometer available for everybody to take a closer look at after the workshop. So if you guys want to take a closer look at it, you'll have an opportunity to.
Can you get that from Amazon?
Yeah, you can buy these on Amazon. You can buy these like locally as well. They run in range between like $10 and $30 if you want to get a fancy one. You can probably spend a lot more and get like a really, really fancy wind meter setup, but you don't need one. This one's like 15 bucks. All right, so we're talking about wind a lot. Talking about wind because as pesticide applicators, we're responsible for managing our drift. So drift management. There is a relationship within drift management between pressure, droplet size, and your distance from the target. And I should also say the opening of your nozzle. So if you have high pressure, that's going to make smaller droplets. And it's also going to shoot your spray further away from you. So smaller droplets are going to travel on the wind further than large droplets because large droplets are heavy and they will fall out of the wind because of gravity. And so your distance from the target, your droplet size, and your pressure, they all impact the kind of the coarseness or the fineness of your spray. So a very fine mist, something with a small opening sprayed with a high pressure, is going to drift very far compared to something that is a coarser spray, something with a larger nozzle opening, something sprayed at lower pressure. You're going to have larger droplets. They're going to fall out of the air faster. So they're not going to drift as far. And it's going to be more predictable what that drift is going to be. So remember, when we're managing our drift, we want to be using the largest size droplet possible to get good coverage of our target. And we can adjust the size of that droplet either by opening or closing the size of the nozzle on the end, if we have one of those adjustable nozzles, or we can adjust the pressure of our pump itself. So if we have like a battery powered backpack sprayer that has an adjustable PSI or pressure gauge, then we can lower the pressure, increase the pressure, adjust the nozzle, get that sweet spot that we're looking for. So that's why it's really helpful to have, for like a backpack sprayer, one of those adjustable nozzles or some type of pressure gauge. And for your boom sprayer, you want a large selection of different nozzles that you can swap in and out based on your needs. Adjuvants. Adjuvants can also be used to help reduce the likelihood of drift. There are lots of different adjuvants that you can add to your spray for any given reason, whether that's to get better coverage or to get more uniform droplets. But what's important to remember when you're using an adjuvant is that that product also has a label. And that label also has PPE and dilution requirements. And so now that you are adding a product to your mix, now you have two labels that you have to follow. So if your pesticide requires that you wear gloves and long sleeve pants and long sleeve shirt, but your adjuvant requires you to also wear eye protection, now you have to default to the more restrictive PPE. So make sure that you are wearing all of the required PPE for every product you're putting into your tank. So pesticides can also affect water systems. And that's especially relevant here in Hawaii because we get all of our drinking water through aquifers in the ground. So what determines how pesticides move through the ground is a combination of the characteristics of that pesticide and the characteristics of the soil. And so we're going to get into specifically soil characteristics and pesticide characteristics on this next slide, but we're talking about the texture and the permeability of the soil, and we're talking about the pesticide's ability to bind to soil and its likelihood or its solubility, how much it likes flowing along with water. And it's not just groundwater that we're concerned about here in Hawaii. We're also concerned about obviously rain, but also irrigation waters and water in canals and ditches. So if you are ever doing an application on like an irrigation ditch side or near a stream or something like that, it's really important that you're using a pesticide that is labeled for aquatic uses or specifically for those types of irrigation ditches or stream beds. The term that you'll see on labels is basically like non-irrigation ditches or irrigation ditches. So that's kind of the terminology that you're looking for if you're doing applications in those areas. And what's important to remember with protecting water systems is whenever we are filling up our backpack sprayer or hand pump sprayer, or the big spray reservoir that we have on our boom, we want to maintain an air gap to avoid backcycling. So what is an air gap? Basically, here is the opening of my tank. Here is my hose. I'm going to hold my hose above the tank. The hose does not go into the tank itself. That one protects the hose from splashback. So the hose itself does not get covered in pesticides. So the next person coming along, not wearing gloves, not wearing PPE, goes to grab that hose to use it to, water their plants. And now they've got pesticide residue all over their hands. It also stops backcycling from occurring. So this is rare, but it can happen. You put your hose into the tank. There's a bunch of pesticide dilution in there. Something happens in the line that causes the pressure to kind of swap. And now the hose is sucking water out of your tank back into the water supply. And that means pesticides are getting into the drinking water. That's something we want to avoid. And it's also a requirement on a lot of labels to contain that air gap. So that is your best practice. Do that every single time. So to get a little bit deeper into pesticide and soil characteristics, if you look at this handy diagram on the right, you'll see that soil is typically 50% open space. And that open space is going to be taken up by a mixture of air and water. Obviously not all soils are exactly like this, but this is a generalization that is good to keep in mind. And so if we're talking about the permeability of soil, the pore spaces, how easy it is for water to infiltrate through that soil. That is a direct relationship to the soil's texture. So the texture, sandy, clay, silt, you are at all familiar with those terms. A sandy soil is going to be much more permeable than a clay soil. Clay particles are the smallest diameter. Sand particles are the largest diameter. And so those larger diameter particles allow for larger pore spaces. So it's easier for water to infiltrate down. Most of the soil that we have in Hawaii is very heavy clay soil, especially in like terrestrial ag areas. So we want to be mindful of our soil type and soil conditions because that's going to influence the likelihood for pesticides to wind up in our groundwater and in other water sources. Another important thing to mention, that little 5% sliver of organic matter. 5% is honestly kind of high for a lot of Hawaiian soils, but organic matter is a component of soil makeup. And organic matter is very, very good at binding not only to nutrients, but also to pesticides. So if you have a soil that is really high in organic matter, it is going to be easier for that soil to retain those pesticides and make sure that they are not leaching out of your application area and getting into the water table. So soil particles, this is where I kind of do a little bit of a tangent because I'm a soil scientist at heart. Soil particles, especially clay particles, they are able to bind to nutrients and other things in the soil that then become available to plants by binding to the soil itself. So that is called the cation exchange capacity. It's the ability for the soil to grab onto stuff. So if you have a soil with a really high cation exchange capacity, or CEC, then it's going to be easier for you to retain those pesticides. And that is a good thing in this case, retaining those pesticides, keeping them in the soil. So if you are working in an area, say you're a farmer or you're in your backyard and you have bare clay soil, and you're worried about like leaching and runoff, what you can do is you can amend your soil with a lot of organic matter. Not only is that going to make your soil healthier and make it easier for you to grow plants in there and, you know, all sorts of other good stuff, it's also going to increase your cation exchange capacity, which is going to make your soil more resilient to pesticide leaching. So some of those pesticide characteristics that we mentioned before, the capacity for pesticides to grab onto those soil particles, that is called adsorption, not absorption. Absorption is being absorbed into something. Adsorption is sticking onto the outside of it. So a pesticide that is highly adsorptive is going to more readily stick to those soil particles than a pesticide with low adsorption. Persistence. Persistence is the ability for a pesticide to stay together and continue to have pesticidal action over time. So a highly persistent pesticide is going to stay pesticidal, you know, for months or more afterwards, whereas a low persistence pesticide is going to start breaking down almost immediately after it gets into contact with light, water, microbes, all sorts of stuff. Solubility. Solubility is just the capacity for that pesticide to mix with water. Something that is very soluble will bind to those water molecules and it will be carried wherever the water goes. Whereas something that is not soluble will fall out of solution due to gravity. So if the water is not flowing, insoluble pesticides will not move with the water. They will just fall out and stay where they are because of gravity. So our worst case, quote unquote, for a pesticide is a highly soluble, high persistence, and low adsorption pesticide. That means it readily mixes with water, so it will move wherever the water moves. It is highly persistent, so it will take a long time for it to break down and stop being pesticidal. And it has low adsorption, so it's not going to stick to the soil. It's going to stay in the water, and it's going to go wherever the water goes. So if I'm a farmer and I'm drastically over irrigating my field, then all of that water that has the pesticide in it, that's going to leach either down into our drinking water, or it's going to get pushed down the mountain into our streams and into our oceans. And those are things that we want to avoid, obviously. So when we are using pesticides, obviously we have target organisms, the pests that we are actively managing, but our pesticide use can also have effects on non-target organisms. So that movement of pesticide through air and water, that winds up in places it's not supposed to be, and that starts impacting endangered species. Also, just pesticides can move not just through the air and the water, but also on us, on our things, on our trucks, on our equipment, as residues, as all sorts of things. Also, you know, if we put a bunch of pesticides in an area and then we do an herbicide spray, it was maybe like 50% effective. So then we have to go in and we have to hand pull. Well, there's still residue on that green waste. And so, you know, we have to be mindful of how we're disposing of those things. So these non-target organisms, they can come into contact with pesticides either through direct contact when you're actually spraying or later as residues. So non-target organisms, typically we're thinking about bees and other pollinators in this case. So there are a few things that we can do to protect bees and other pollinators from pesticides. One is to time our application when bees and pollinators are not foraging. So in the evenings, at the end of the day, once the sun starts setting, bees and other pollinators, they go home, they're ready for bed. So this is our time when we can spray and not be worried about direct contact. Obviously, there's still going to be a residue left over. And some products are designed to have residues that last for a long time because that provides long-term control against the pest. But if we have a lot of pollinators in our area, then we want to start considering using pesticides that have less residual action. Something with a residual action of under 12 hours. In that case, We do our application in the evening. 12 hours later, it's 5 a.m. Pollinators haven't shown up yet. So by the time the pollinators get back to our yard or our field or wherever we're applying, the residue is gone and it's now safe for them to come back again. So we are really only in this case exposing the pest to the pesticide and not the pollinators. And just like with humans, non-target organisms are impacted by pesticides in the exact same way. So there could be acute effects where they are immediately impacted and they just kind of fall over and die right there. There could be a delayed effects. So they are weakened by the pesticide. They go back to their colony. Again, we're talking about bees in this case. They are then, feeding their neighbor bees and they're exposing other bees to this pesticide that's now in their system. And there can also be chronic effects. So long-term, basically like chronic conditions that develop because of pesticide use. So if bee gets exposed to a pesticide, it is now weakened. It can't fly as far. It's not able to collect as much pollen. So thankfully for that bee, it lives in a big colony, so it can get support from others, but impacting the fitness of the pollinators is going to lower their viability in the landscape. So we want to make sure that we're only impacting the pests when we're doing any type of pesticide application. You had another question, sir?
Yeah, do you have a list of those recommended product?
So no, we don't have a list of recommended products. Typically, as a state department, we don't recommend specific products because we don't want to be directing business, to private companies. Obviously, we can talk about active ingredients. I can talk about things that I've used personally, but if you're interested in finding pesticides that have low residual toxicity, I recommend shooting me an email so I can send you some like links and resources. But basically, you're looking for residual toxicity, a pesticide with low residual toxicity. So if you're looking in your storage unit, you're like, these are the pesticides that I have. So like, this is just the first one that came off the top of my head. This is not a great example, but Merit 75, water-soluble packets, very commonly used in the landscaping industry. Not a great example because it has a long residual toxicity, very harmful to pollinators. But what you could do, you could go to Google, you could type in, Merit 75 WSP residual toxicity. And that'll give you some ideas in terms of how long that product is going to be active in the environment.
Yeah, so to protect the environment, why not the state would make a regulated list? So therefore, we keep the environment safer.
That's an interesting idea. Like I said, we have to be very careful about making specific product recommendations because we don't want to be directing business to private companies. But that's something I can talk about with some of my colleagues and see if there is some gray area wiggle room for us to be able to put out a resource like that.
Yeah, it's not a business, it's to protect the environment.
I understand. I do want to say that at any time, if you are like trying to look up information about your pesticide and you have questions and you're unsure, you can always reach out to us directly and we can do like a little one-on-one consultation conversation type thing. My contact information will be available at the end of the presentation. I'm available whenever you guys need me.
Can I throw in 2 cents?
Please, yeah.
On the environmental impacts thing, any licensed pesticide, if used correctly, the fact that it's licensed should mean that if you're using it correctly, you're not impacting the environment. But there's certain pesticides that have higher risk if you misuse them or if there's like a rain event right after you use a highly soluble something. Like for example, the imidacloprid, right? It's a systemic insecticide. It impacts pollinators, but most of them on the labels it'll say remove flowers, right? So if you're doing that, there's not going to be impact to bees, right? So following the label is very important to be able to use them safely. Yeah.
All right. So something that's really important when we are choosing pesticides is understanding our pest. There are lots of different kinds of pests that we could run into, from vertebrates to insects, to weeds, to bacteria, to fungi. Within insects, there are these 2 different types of growth. It's important to understand which area your pest falls into. There is incomplete metamorphosis, where basically you start out as a little tiny version of your adult self, and then you just get bigger and bigger and bigger and bigger over time. And then there is complete metamorphosis, where you actually go through a number of form changes. So, obviously, butterflies, caterpillars, cocoons, that is complete metamorphosis. And we want to understand what side our pest falls into, because that's going to inform our decision-making process in pest control. So, if we look at this example on the left, this cricket or this locust, this insect throughout every stage of its life cycle basically has the same behavior. It has the same food, and it has the same habitat. Butterflies, cocoons, and caterpillars all have different food, different habitats, and different behaviors. So we need to be mindful of those habitats and behaviors, because that's going to inform how we control that pest. So, caterpillars, they will actively eat the leaves. So if we have something, a systemic in the plant or something on the leaf itself, that is going to be effective against those caterpillars. But butterflies obviously are not actually eating the plant. They're just taking the nectar. Oftentimes, butterflies are beneficial. They're pollinators. But sometimes, especially for cases where the caterpillar of that butterfly or that moth is an especially voracious pest, then that adult insect becomes more of a nuisance than a benefit as well. So we want to consider not just ways to control the pest itself, but also the spread and distribution of that pest. So it's really important to understand the pest that you're dealing with and its life cycle, so you can make those choices about timing and specifically what you're going to use. Also, oftentimes, when insects are younger, when they are actively growing, they are more susceptible to pesticides. So if you can get them before they get to their adult phase, that's going to be all the better, especially for some insects that don't even feed as adults. All they do is breed and lay eggs. So if you have a large population of adults and you're putting out a pesticide, a systemic something, or you're spraying it on the leaves to protect your plant itself, well, those adults aren't eating your plant. They're just laying a bunch of eggs on it. So if you're not also using something that's going to hurt the eggs, then you're not actually helping yourself. Something that's important to keep in mind with insects specifically is the mouth part. So the type of damage that an insect does to a plant or to a structure is directly related to the shape of its mouth. So different mouth parts, different mouth shapes, different mouth sizes show as different damage on leaves or on structures. So we're not always going to have the benefit of being able to see the pest itself when we are monitoring. Sometimes we're only going to see the damage from the pest. So it's important to understand the damage that piercing and sucking mouth parts do compared to like chewing and sponging mouth parts, or even boring mouth parts. So being able to recognize those signs of damage is really, really helpful when we are trying to figure out what is causing these pest problems in our yard or our field or our homes. So there are two main distinctions within weeds between monocots and dicots. Now, what does that actually mean? A cotyledon is that first little leaf that comes out of a seed when it germinates. Some plants have one, some plants have two. No plants that I know of have three. Monocots and dicots are very similar, but they have some key differences. And those key differences are exploited by pesticide companies to create pesticides that only affect monocots and pesticides that only affect dicots. So all monocots have parallel veins, whereas dicots have netted veins. Grasses, sedges, things like bananas, those are all monocots. Whereas like broadleaf weeds, things like Chinese violet, those are dicots. So if I have a yard, really nice, St. Augustine grass, And I've got a bunch of Chinese violet growing all over it because my neighbor does not do a good job of managing their yard. Well, what I can do is I can grab a pesticide that only works against broadleaf species, and I can spray that all over my yard. And then I don't need to worry about killing my grass at all because that pesticide isn't going to do anything to my grass. Same thing the other way around. I can have a very nice shrub next to my house and there's a bunch of grasses growing underneath it. I don't want to get down on my knees and pull all those grasses out like every other week. So I'm just going to take an herbicide that only works against monocots, and I'm going to spray that there. It's not going to harm my shrubs. It's only going to kill the grass. Something to keep in mind with monocots and dicots. They have developed strategies to regrow from damage. So grasses have these underground structures called stolons. Other plants have things called rhizomes, and they are able to regrow from those underground structures. So, you can have some nuisance grass, you can mow it all the way down to the ground and think, oh, well, it's dead, it's gone, it's mowed all the way down. There are stores and reserves of energy in the ground, spots that it can regrow from. Even if you were to pull, the clump of guinea grass out of the ground, there could be stolons left over underneath that you did not get, that broke off as you ripped it out of the ground. It'll regrow from those stolons. So for those types of grasses, we want to make sure we're using something that is translocatable. So that means you spray it on the leaves, and then that herbicide spreads through the rest of the plant. It gets into the root system and it kills the roots. So that way we don't need to worry about it regrowing after the fact. It's already dead. Broadleaf weeds, those have a little bit of a different strategy. Yeah, they can regrow from cut stumps. I think we've all seen trees that have kind of resprouted from a cut stump before. But broadleaf weeds, especially, so let's imagine a shrub. A shrub has lots of different branching points going in lots of different directions. Each one of those branching points has what's called a lateral bud or lateral meristem. That is a basically clump of stem cells that is just waiting to be activated by a plant growth regulator to become a new stem or a new shoot. So if I have a big shrub that I want to get rid of, and I do a spray of herbicide over the top of it, well, that's going to kill all the leaves on top that it touches. Good, that was my goal in doing that. But those lateral buds can still be intact. And so the plant will start regrowing from those lateral buds. So I may have injured the plant, but I did not actually kill it, and it has started regrowing. So we want to be knowledgeable about our pest so that we can plan our application accordingly. And talking about application timing, this is especially relevant with grasses. Actually, hold on. I talk about this in a few more slides. Let me hold on to that thought. Here's a quick close-up of the veins. So on the left, this is a broadleaf species. You can see it has that netted vein structure. Whereas on the right, that is a monocot. The veins are very parallel. This is really, really easy to see. All you got to do is take a leaf and hold it up to the light. Okay, annuals versus perennials. So an annual is a species that basically grows, creates seed, and dies all within the course of a year. Perennials are things that live for 2 years or more. This is where timing of your application is relevant, because if you have an annual grass that is, growing, and then suddenly starts putting out a ton of seed, and then you go to do your spray, well, there's already a ton of seed, and that seed has probably dropped and is already in your soil. So now you're going to have to go and do that all again the next year. So if you get to that grass before it sets seed, then you don't need to worry about the next year's crop. Alternatively, what you could do, because that's an annual grass, it's going to die, you could wait for that grass to go through its life cycle, die, drop its seed, and then use what's called a pre-emergent pesticide. So that is something you apply to the soil It does not actually kill any plants. It stops seeds from germinating. So there are different strategies, different products that you can aim for, depending on what you think is easier, what you think is more affordable, and what you're able to do with what you have access to in the sites that you're working in. So that's important to keep in mind, the timing and the life cycle, not just for insects, but also for plants.
Sure, is the pre-urgent considered organic or non-organic?
There are pre-emergents that are organic. There are pre-emergents that are not organic. Organic has nothing to do with, you know, the type of pesticide that it is. Organic is just a term that's used, a label that gets put on a pesticide that is, you know, non-synthetic. This workshop is not really for getting into the whole organic versus non-organic debate. We actually did a whole workshop on that already. But organic and pre-emergent are non-exclusive. Okay, integrated pest management. This is a sustainable approach to pest control. I am now going to quickly read the very long, wordy definition. It is the coordinated use of pest and environmental information with available pest control methods to prevent unacceptable levels of pest damage by the most economical means and with the least possible hazard to people, property, and the environment. Otherwise known as think before you spray. So if we want to solve pest problems, there are certain things that we have to do. We have to identify the pest and determine whether or not control is warranted. So, you know, if there's just a few aphids on my plant, I don't care. Whatever, there's just a few aphids, it's not a big deal. If there's a million aphids on my plant, okay, now I want to do something. We have to understand what our goals are for pest control. So, you know, I have a walkway in my front yard and there are some, you know, little weeds and grasses growing in the cracks. What is my goal? Is my goal to have zero weeds and grasses at all? Or is my goal just that I don't want any grasses sticking up, like through the cracks? I can tolerate some moss, I can tolerate some other things. I just don't want anything tall sticking up and getting in my way while I walk. So what are our goals for pest control? We need to know what tactics are available. So not just what pesticides we have access to, but non-chemical control methods that we can utilize so we don't have to use pesticides. And we should only be using pesticides when we absolutely have to, because they are dangerous and they are complicated. So if you don't need to use them, don't use them. We also need to evaluate the benefits and risks of each tactic. So we need to really think about what we're doing. So yeah, pesticides are dangerous and they're complicated, but sometimes the value of that tool far exceeds that risk and that danger. So that is a evaluation that we need to make every time we're using a pesticide. And we want to choose a strategy that's going to be effective and is going to cause the least amount of harm to people in the environment. So yeah, I could take a pesticide, I could take a bit, like a ton of herbicide, I could spray that out like every other day within, you know, maximum annual use rates, and that would work. But, you know, if weeds are easy enough to handful, I should just do that. If it's not going to take me that much longer, if it's not going to be that much harder, just handfulling. It's way safer for me, it's way safer for the environment, it's way safer for my neighbors too. And we want to make sure that we use all of our tactics and strategies correctly. So just like any tool, we want to be using those tools accurately. So something that's really important with integrated pest management is to establish what is called an action threshold. So that's the point at which action must be taken to stop harm caused by pests. So what is your action threshold as a farmer, as a homeowner, as a, you know, termite inspector? They're all going to be different and they're all going to be context dependent. So you need to make that distinction yourself, whether it's you as the farmer who is making that call or your client in their home, who if they see one single German cockroach, they will literally die. So there is zero tolerance for pests in that case. You know, oftentimes there is going to be some tolerance for pests, but there are going to be occasions where there's none. So step number one, we want to identify the pest, understand its life cycle and its behavior. Step number two, we're going to prevent the pest. So we're going to reduce its food sources, its water access, and its shelter. This works really well for vertebrate pests like rats and mice. This does not work as well for insects and things like that, but it can kind of work with weeds. You know, if we have like an area in our yard that's full of weeds, maybe it's because our hose is leaking and there's just more water in that area, and that makes it that much easier for those weeds to establish. So maybe we fix our water lines, or, you know, we have an area next to our house that is, you know, really, really grassy and really, really weedy. So maybe what we do is we take some shade cloth and we make a little shade structure. So now not only do we have a place to put our like cool little nursery plants that we're growing out for our yard, but also those grasses have less access to sun. So they're not going to grow as much. So it's going to be easier for us to manage them, keep those weeds down. Then we want to control the pest. So whether we're using biocontrol, physical mechanical control, cultural control, or chemical control, this is where we actually have to step in and do something to get rid of the pest. And then we want to evaluate our actions. Were they effective? Can they be improved? You know, we don't just do the same thing over and over again if it's not working. We want to evaluate what we're doing and think critically about what we're doing. It's also really important to monitor your pest population so you can understand what's happening with your pest and what's happening with your site. And if I had to ask, at what step do you think you should be monitoring your pests? I am asking. Oh,
Right.
Control.
in the beginning? What if I told you that you need to monitor your pest populations at every step in this program?
Absolutely.
At all times, you should be monitoring, you should be watching, you should be thinking about the pests and about what they're doing so that we can respond accordingly. So sometimes our pest control fails. There are multiple reasons why this could happen. We could have identified our pest wrong. We could have used the wrong product, the wrong rate. We might have the right product, the right rate for the right pest at the wrong life cycle. There could also just be extreme pest pressure. So one application just is not going to be enough. You can also have reinfestation or reinfection. So, you know, I'm in my backyard, I do a spray, I kill all the whitefly in my yard. My neighbor has a ton of whitefly, the whitefly in their yard just move back over to mine. Sometimes you just can't win, but that is a reinfestation or reinfection. And sometimes the problem with our plant isn't even caused by a pest. It's an abiotic disorder. So we actually just need to fertilize or water more, or honestly, water less. But sometimes what can happen is you can have the development of resistance within your pests. So if you spray the same pesticide over and over and over again, that population of pests is more likely to become resistant to that pesticide. So if we look at this diagram on the right here, we can see in the first generation, before pesticide application, we have almost all blue guys and one red guy. The red guy is resistant to that pesticide. We do a spray that kills most of the population. Oftentimes, in fact, nearly every time, you're not going to kill 100% of the population. There's going to be some left over. And so within these left over, we have two blue guys and one red guy. So now when the population comes back, now we have roughly a 50-50 split between red guys and blue guys. When we go and do our reapplication of that same product, now 50% of that population is resistant to that chemical. And so 50% of that population isn't going to go anywhere. So that's why we want to be rotating through different types of pesticides. And what's important isn't necessarily different active ingredients, but different modes of action. So mode of action, or mode of attack, as some people like to call it, is a category that gets assigned to a pesticide based on its chemistry. Those categories are basically, numbered and have letters on them. There is something called the Insect Resistance Action Council, or IRAC, that creates all these categories and maintains all these classifications. Those are things that you can look up online, but oftentimes the label itself will tell you what category that pesticide is in. And within those labels, there's often a section on resistance management, and they will give you tips and tricks for things that you can rotate in, but there might also be specific restrictions about the timing and use of that product. So for a lot of like imidacloprils, like Merit, my mind always goes back to Merit because I've done a lot of work in the landscaping industry, and there's a lot of Merit in the landscaping industry. That is a category 4 product. That label has specific restrictions about its timing. So you can only use it once per week. And after multiple applications, you have to switch to a product that is not in category 4. So it's important to understand what these categories are so that you can actively rotate through different modes of action. And so when you have a pest problem and you're starting from scratch with 0 pesticides that work for that pest, you don't want to just buy one. You probably want to buy two with completely different modes of action, so you can do a bit of a rotation. And that way you're going to reduce the likelihood for resistance to develop. Question.
Sorry, you mentioned about a category 4. Could you explain a little bit?
So
First time I-
category 4 is all imidacloprils. I believe it also includes all the neonicotinoid pesticides. If you go online and you look up IRAP, like categorization, or just search pesticide category 4, that's going to give you a list of all of the active ingredients that fall within that category. And so that's why it's important not just to cycle active ingredients, but actually cycle through a different category. Because sometimes different active ingredients have the same mode of action.
When you say Iraq, is it India? Romeo, Oscar,
Sorry?
when you say Iraq, is that
Oh,
India.
IRAC,
okay?
Insect Resistance Action Council.
Got it.
There's a set of classifications for insecticides, there's one for herbicides, and there's one for fungicides. So a category 1 insecticide is not the same as a category 1 herbicide, but insecticides are already different from herbicides. So I don't really think we need to worry about getting those mixed up.
Thank you.
So we talked a little bit about non-chemical control. So there are some different types of management that you can utilize that is not pesticides. So there is this concept called cultural control, using things like cover crops, pruning to increase airflow through the plant to reduce the incidence of fungal growth, and also spacing. So if my plants are spaced further apart, it's harder for insects to crawl from plant to plant, from leaf to leaf, and spread throughout my field. Obviously, mechanical control, that's pretty easy to understand. You know, tilling, I have a bunch of weeds in my field, so I'm just going to till them in the ground. Now I have organic matter. So that problem is now a benefit. Also, just like pruning a especially infested part of a plant. So like aphids, they really love to suck on those like fresh leaves, those new leaves. So if I see there's a stem on my plant that just is covered with aphids and there are no aphids anywhere else on the plant, I'm just going to take my pruners, I'm going to clip off that stem, I'm going to toss that in the trash. I don't need to get at my spray bottle. I don't need to put on my PPE. I don't need to do all my WPS compliance. I just use some clippers. Problem solved. Exclusion, so fencing, greenhouses, quarantining your plants. So like when you go to a nursery and you buy new plants, you set them up in a little quarantine zone before putting them in your yard. Make sure there's no little fire ants or anything else in there. Those are exclusionary methods. We can use those to make sure that pests aren't getting to areas that we want. So oftentimes, you know, if our pest is birds that are coming in and eating like our hot peppers or things like that, you know, rather than getting really fancy with like, there's this bird product in the market that like smells really gross and you apply it with a UV dye. So the birds associate this UV like color with the bad smell. And so they stay away from the air. Just get a screen. Just get a screen and protect your plants. And then the birds physically can't get to it. Same thing with like, you know, bird spikes on your patio. That's going to work way better than trying to spray a bunch of nasty smelling stuff all over the place. So when we can use exclusion or like mechanical control, it's a really good option. Biological control. So that is things like the natural enemies. So not just like biocontrol agents, they get released as part of a coordinated biocontrol effort, but also just like predatory insects in your yard. So this is another reason to avoid broad spectrum pesticides, pesticides that will kill any insect they come into contact with, because not every insect in the landscape is a pest. Many of those insects actually eat the pests. So if we have a healthy ecosystem of insects, then they can help us manage our pest populations themselves. So we want to be sure to promote those natural enemies as much as we can. That's what we can do as individuals. The biocontrol agents, those are released as part of, government-funded projects, big research projects. That's not something that we can do on our own, but it is a very useful and crucial tool that has been used effectively here in Hawaii when done correctly. You can also utilize plants that are just inherently resistant to the pest. This is especially useful when we're talking about fungal pests or like viruses, other plant diseases. So if we use a cultivar that is resistant already, we don't need to worry about, spraying a fungicide all over the place. It's already resistant. Keeping things clean, similarly, can help reduce the onset of fungal diseases. And also can help protect from some other types of plant pathogens. And then finally, we come to chemical control. So within chemical control, there are different distinctions, different classifications for pesticides. You have biorational pesticides, which are oftentimes organic products, can be considered biorational, but there are many organic products that are considered more conventional pesticides. Biorational pesticides are more so things like BT or Bacillus thuringiensis. This is a bacteria that you can spray on your plants, which will infect and kill insects. That is a biorational pesticide. Whereas, to go back to my tried and true example, merit, imidacloprid, is a conventional pesticide that is synthetic. It is designed to kill. That's what it does. You have a question?
Yes, for your biological control, is there a company that we can buy from Hawaii?
No.
Why not?
So you cannot so on the mainland, you can do things like buy ladybugs and have them shipped to you and then just put them into your yard. You can't do that in Hawaii.
No, I mean, do we have in Hawaii, like a company in Hawaii or your department
No, there's no company that is like,
or a provider?
that's not how biocontrol works. So biocontrol is like a program that is done through like a controlled release. So most recently, the Wolbachia infected mosquitoes. So those are mosquitoes that have basically been infected with a bacteria that makes them sterile. So you release those mosquitoes into the landscape. They breed with the other mosquitoes, but there's no generation after that. So after mosquitoes breed, they die. So that decreases the population of mosquitoes in the area. That is a government program, which is not something that's being done by a private company. So biological control is not really a product that you buy. It is something that you do to like manage, especially, or something that like governments do to manage especially damaging pests. So the erythrina wall wasp that was attacking Willy Willy. There was a biological control agent that was released by the government to control that pest. Coconut rhinoceros beetle. We are currently developing biological control agents to deal with that pest here on Oahu and within the rest of the state. There are some permits that recently got approved to bring some viral samples over from Guam, I believe, to start doing some of that testing. That process is ongoing. That is something that happens within a research laboratory by PhDs. That's not something that you can just do in your backyard. If we're talking about like, again, biocontrol that we can do, that is promoting a healthy ecosystem of pests, having those natural enemies, those natural predators to self-manage our pest populations. It's not really a product that we can just go out and buy. Okay, so that's integrated pest management. That's environment controls. That is soil and pesticide characteristics. Do you have any questions about that before we move on to the next section?
Let's move forward.
Great. I'm going to hand it over to my colleague, Mark, and he's going to play a fun game with you all.
You sure it's fun?
I think it's pretty fun.
Okay, cool. Glad you do. All right, so now that we're kind of done with the introduction to different pests and different management techniques. I'm gonna ask you guys to ID some pests because pest identification is the most important thing for management, right? If you don't identify the pest correctly, you won't be able to manage it correctly. So, what do you guys think this is? What pest is this? White flies. Ooh, yeah, we got some smart people in here. Yeah, so we have actually, can stay on the slide for a second. We have different life stages here too, right? So we have the adult white flies. So you can see they look like white flies, right? Well, what are these things over here? These are still white flies, but they're immatures, and then there's some eggs in there as well. So you'll see different stages of life of a pest. This is a super heavy infection, right? So or infestation, excuse me. So hopefully you won't be seeing something this bad that often, but you may, right? But just know that there's different life cycles or different parts of the life cycle for different pests. So like that kind of looks like, you know, this eggs and immatures kind of look like scales, right? But you see the adults there, you know, now you know what they look like at that life stage.
How do you get rid of them?
What's that?
How do you get rid of them?
White flies? Ooh,
Yeah, hard.
yeah, they are hard to get rid of. There has been over reliance on pesticides for. Let me go back to that slide then. On to manage white flies, so they're like resistant to a lot of pesticides now. However, what you can do are other management techniques. For instance, pruning. If you thin out the branches, they don't like airflow. So if it's very dense and there's a lot of branches and leaves, they'll infest in there like really heavily. But if you prune branches so that there's air gaps, the wind's coming in, it'll reduce populations. You can also use like a sprinkler on a timer to spray the bottom of the leaves. So that's where they hang
Soap and
out.
water,
What's that?
soap and water.
Yeah, okay. Soap.
You know,
Yeah, you can use soap and water if it's soap that's either in registered insecticidal soap or something that's on the EPA exempt list for soap.
oh, okay.
So be cautious when using soap because there might be a lot of different active ingredients or ingredients inside of the soap, which may or may not have EPA exemptions for tolerances and stuff. But in conceptually, yes, right? Soap will kill white flies, like soap and water. So the soap and water example, right? Like soap is surfactant, right? So it helps the water spread over the insect and also permeates the waxy like coating on the insect so that it drowns. And then also if any of them survive that, it'll dry out because the waxy coating isn't there. So soap is pretty effective if it is a registered product or an exempt product, yeah? Topic for another day. Okay. Okay. Does anybody know what this test is here on the left side over here?
Scale?
Yeah, what kind of scale is it? It is a scale, but for management, is it a soft scale or hard scale?
That's hard.
So that matters for managing scales. We don't know.
There's still different kinds there, no?
We'll just focus on the left here, for now, yeah. So this is a cottony cushion scale, soft scale. They're pretty big too, so you can just squish it with your fingers. But the point there is with the difference between hard scales and soft scales is that soft scales, you can, spray contact pesticide with like soap, insecticidal soap, for example. It'll be quite effective, whereas hard scales have this like armor on the outside. And typically you would need to use a systemic insecticide to manage a hard scale, yeah? Yeah, yes.
If you use Merit 75, and then, they tell you limit how far you can go and seasonal and all that. If you don't use Merit, are there A, B, and C, or it's?
Yeah, there's a lot of products that are registered for sucking insects. So like look on the product labels. It's a good indicator if it should be effective or not if that pest is on the label, yeah? But make sure that your site is on the label. So whatever plant you're spraying should be on the label. That's a requirement.
I didn't know there were, sounded like there was only a few systemic insecticide.
Yeah, for systemic insecticides, there's not too many. And it depends on really like what industry you're in as well. Like if you're in ag or landscaping or what you're doing. There's not that many options available. Yeah, but you can, we'll get into it in the next slide, but there are some management techniques you can use with hard scales that will help reduce the populations that aren't systemic insecticides. Yeah. Next slide, though, yeah? All right. Anybody know this over here, this pest? On the right side?
Scale.
Yeah, it's another scale, right? Is it a hard body scale or a soft body scale? That's a soft body scale as well, yeah. It's just different type, very small, flat. You can see different life stages here too, which is pretty cool. You have the crawlers, these little things, they crawl. And then there's the adults that just fix in one location, they're there forever. So same kind of management technique, although they're a lot smaller. So you can still use your fingers to smash them and stuff, but you can use contact insecticides here and they'll work, right? You can also use water, spray them off. You know, things like that will work. Also, for both of these, even for hard scales as well, what kind of mouth parts do these scales have? You guys know? Sucking, right? They have sucking mouth parts. They sit there and they suck the plant and they poop out sugar water. Okay, that's their byproduct. Poop out sugar water from the plant. And then the ants come, eat the sugar water, and then defend them from their natural enemies. Yeah, so if you have a lot of scales around, probably have black city mold, probably have ants around too. If you manage the ants, right? So you're managing the protector of these scales, then, or whiteflies also have the same thing, right? And mealybugs, you know, all the sucking insects are similar, right? If you manage the ants, then the natural enemies will help reduce populations here of the scales as well. So there's different management techniques that you can use without just relying on imidacloprid, for example.
Mark, can I add something?
Yeah, you can, totally.
So yes, hard bodied scale, armored scale, they do have those piercing and sucking mouth parts, but they actually don't produce honeydew like soft bodied scales do, for whatever reason. Yeah, really.
I did not know that. Okay, thank you.
Yeah. So if you're dealing with that hard body scale, you don't need to worry about the black city mold and the honeydew, but they absolutely are still a piercing and suction pest. So if you do see that type of honeydew, that black city mold, that is a good indication that you're working with a soft scale.
Thank you for educating me, Max.
That's a question on our exam, so I want to make sure that it was pointed out.
All right. So we have the next slide here. I think we gave several hints to what's going on here, but on the left, do we know what this is? Low day lag scale. Is it a soft body or hard body? Is it an armored scale or soft body? Armored. This is an armored scale, so it's a lot harder to kill, like with your fingers or by like spraying water on it. They have this hard kind of like shell that keeps them safe. What are these little red guys over here?
I heard it.
You heard it? Okay, yeah, those are the crawlers, the immature ones. So you can still manage those with like your insecticidal soap or just spraying down with water. The crawlers are going to be susceptible. You know, they don't have that big armored shell on them. So you can still use contact insecticides to help reduce the population here if they're in that life stage, right? As they are here. But it's not going to manage the adults in the egg laying.
So how do you do? Just cut them off again?
Yeah, so like for here, this is where you would need to rely on systemic insecticide to handle this. If you have a really bad infestation like this, I would remove the plant. Like, just gonna make everything worse in the whole area, right? Like it's gonna move from this plant to the next one.
These are all in Hawaii, right?
Yeah. Okay. We done with this? Okay. How about the example on the right side? We know what that is? Ooh, yeah, it's plumeria rust. Okay, not a scale anymore. So this is a fungus over here. This is pretty common. You see it on like every plumeria tree ever. And it's very obvious. It's called rust. It looks like rust. You know, it makes sense. It's a fungal pathogen. And you can see, where is it growing? Is it, or I should say, where is it showing its signs? On the bottom of the leaf, right? It's important. There's a common theme here with a lot of different pathogens and pests. A lot of them like the bottom of the leaf. Yeah, so like your whiteflies, aphids, yeah, mealybugs, a lot of them, and you know, fungi as well, like your downy mildew, they'll all be showing on the bottom of the leaves. So if you're gonna treat them with pesticides, you gotta spray the bottom of the leaf, right? Unless you're using systemic, right? And then it'll translocate. But keep that in mind. Like if you're spraying a contact insecticide and you're spraying the top of the leaf, it's not gonna do anything. Yeah.
Yeah, do you guys have any cure for white rust?
I'm sure there are products available.
You just need to use a fungicide that is labeled for your site, your crop, or whatever it is.
For white rust?
For a fungal infection, use a fungicide.
There's like a powdery mildew, which is why I'm not familiar with white rust myself, but check the label. If the label says that disease on it, it's a good chance it'll be effective on it. Not always, because you know resistance develops. Yeah.
So I was wondering if you get done.
You can check CDMS. So like it's a website. So we'll go to CDMS Advanced Search, and in there you can search for fungicide and then type in your pest, and it'll tell you what options there are. And then I would cross-reference it with the Department of Agriculture and Biosecurity's website of licensed pesticides in Hawaii to make sure it's available here, because not everything is. And some things are state restricted here where they're not on the mainland too.
If I had a customer who had these problems, could they call you and you guys come out, check it out for them?
Okay, yeah, as my job as an extension agent is my job is to help the public with these problems and understanding. However, it's not for recommending products. It's not for treating. It's not for. I'm not a commercial business. I'm here as a public educator. Max as well as a public educator. This is our job. So we can come out, but we're not going to treat it for you, and we're not going to recommend a company or product specifically for you. We'll help you understand what the problem is and what the solutions could be. Yeah.
Yeah. Just very quickly on that note, like Mark said, my job is not to tell you what to use. My job is to tell you how to use that thing correctly and safely and according to the law and the label and everything else around it. So that's why I'm very resistant towards making specific recommendations, because I'm not supposed to do that.
Mm-hmm.
I'm just supposed to tell you how to use your product correctly. So I will help you find lists of things. I'll help you find databases, but at the end of the day, the best way to use Mark and I as a resource is to give us a list of things that you want to use, and we'll tell you which would either be appropriate or not appropriate, and which ones we think will be more effective or less effective.
What if the homeowner doesn't understand about what type of product to buy? I mean, you take a regular homeowner, even most of us here.
Yeah.
Like, where do we start from, you know?
So Fred, that's actually a really great point. I'm glad you brought that up. If you have a client or someone who is asking you a bunch of questions about pesticides and you run out of answers, give them my contact information. Have them call me and we can have a conversation about pesticides. I am an expert. I am a public resource. So do not hesitate to give out my information. Definitely direct those questions towards me. That is my official duty. That is my official job. That is not exactly Mark's job and Mark's duty. So please,
help as well.
yes, he can't help, but first direct, yours or your client's questions about pesticides, to me primarily.
And next, will we find you here, this building?
No, I do not work in this building. I actually work in town. My contact information will be available at the end of the presentation, and you all should have my contact information from the emails that you got about this workshop in the first place.
Okay, so this is a little bit different. Maybe we can like gear towards the structural crowd if there's anybody that's structural pest control in here.
There are.
Yeah, all right, cool. So can we identify what these are? Maybe we start on the left.
Termites.
Termites. Yeah, they're both termites. What kind?
Soldiers.
Not cats.
What kind? Yeah, what
What species?
species?
We took this termites.
On the left.
Very well.
Drywood termite. Very good. There's some context clues here, so I'm not able to identify morphologically myself, but there are some context clues here to let you know what type they are. So how about the termites on the right side? Subterranean. Why does this matter when you're treating or giving recommendations?
Different type of treatment.
Different treatment, right? So the customer says, I have termites. Cool. If you tent the house and they have subterranean termites, you're just wasting money, right? If you put like ground bait stations and they have drywood termites, might not help that much, right? So knowing what type of termite you have will determine what your treatments are, right? Drywood termites, they nest and have their colony inside of the wood in the house, whereas the subterranean termites have the colony underground and then they come up to feed, right? And you'll see like mud tubes and things like that. Really matters for what your treatment is. Like Max mentioned, neither of us are like pest control people ourselves, but this is the point here is that knowing which you have is going to determine how you treat. And if you do it incorrectly, it can be very expensive, right? And ineffective. Okay, cool. Got some good eyes in the room. So I'm glad that the structural people know. All right. Now we just see some symptoms, right? We're not seeing signs anymore. We don't actually see the pest. But what do you think could have done this? On the left. Caterpillar, why?
Right around.
Yeah. Biting around from the outside in. They tend to eat from the margins towards the middle, right? How about on the right side? Beetle. Why? They're eating all through the leaf, not from the outside in, but they're eating just pieces of
Is
whatever.
that from a rose plant or the Chinese beetle or something?
Yeah, this is Chinese rose beetle damage. I don't know the plant. This is on the.
My rose is just for that.
You know what plant this came from, Max? Yeah, okay. I also don't know. But anyways, here we have the Florida fern caterpillar. So we call you're correct. It was caterpillar eating from the outside in. And we have Chinese rose beetle damage feeding on like the middle of the leaf, right?
Oh, Mark, can I add another thing very quickly?
Yeah, sure.
So just because that says Florida fern caterpillar, that doesn't mean that they aren't here in Hawaii. The Florida fern caterpillar is an invasive species. It is here in Hawaii, definitely on Oahu. I don't know about the other islands. I've never run into it on the other islands, but I can tell you from my time doing like horticulture and landscaping stuff, kill a lot of those Florida fern caterpillars here in Oahu. So all of these pests are things that you will find here in Hawaii.
All right, we got a smart group. Everyone's been getting pretty much everything, right? How about this? Do we know what caused this damage? We don't see the actual pest here. Those are hints, by the way.
Here we go.
So all that bark is missing at the base, right? It could be. In this case, we have rat, right?
Yeah.
Kind of a small twig, but on a larger tree maybe, right? So if you're treating for, like some of the fungal diseases kind of look like this too, right? You get like corky bark. you start putting a fungicide on this, is it gonna help you? No, right? So identifying your pest properly is like the first step to making sure you have a proper treatment and a successful treatment. Okay, we got some more in here. Just kind of go through these a little bit quickly. Does anybody know what these guys are? Aphids, right? They're another sucking insect, kind of like the scales, mealybugs or whiteflies, you know, they're all sucking insects. This guy I've worked a lot with. I hate them. They're also here. Kind of hard to tell, but especially from this angle, if it was on the top, it'd be better. But I'll give you a hint, or I'll give it to you. That's a bee armyworm. They eat grasses a lot, so I worked with corn a lot before, and they're always there. How about in the middle? Spider mites. How do we know that's spider mites and not spiders? You're correct, by the way. It is spider mites.
At the bee gun?
Yeah. The webbing is in intra leaf, right? It is closing one leaf, making it like an enclosed habitat for them. It's protecting them. You can see them physically in there, those little red dots, right? Whereas spiders typically go from one plant to another. They're using their web and string between plants or between leaves. Whereas spider mites will be like within a leaf trying to curl it up and make their like little shelter. Also, they're like those, this is a really bad infestation, but like little red dots all up in that. So you can see, and then you'll feel it after you're working in it, you'll be itchy all over. How about this guy on the right side? We're not seeing the actual pest here, but we see some symptoms. Nematode, right? Not nematodes. They create this symptom, this big galling on the roots. Okay. Is how you identify the pest is identifying the pest correctly is going to help you find a solution that works, right? That's the first step.
Are there any natural insects that eat the whiteflies?
Yeah. Like pretty much all pests have natural enemies. To promote natural enemies of pests, some of the things you can do is, one is the pruning that Max mentioned earlier, so it kind of makes the populations go down of the pests. Another really important thing is cover crops. If you have flowering plants, so like cover crops not only for weed suppression, right? But if you like have a farm and you rotate, right? You have corn this season, then you have a broadleaf cover crop, then you spray your your grass herbicides on that cover crop to kill your grassy weeds on your off season. You have flowering plants. Those natural enemies come and suck on those plants. They make their babies. Then they go to eat your pests in your cornfield, right? Or the same thing can apply in a house or landscaping. You want to have flowering constantly through the year. Like we don't have like a winter here, right? On the mainland, though, it'll just like everything will explode in the spring and summer and then kind of die out. But here we have to have constant flowering throughout the whole year to support the natural enemies of the pests. So there's a lot of like little wasps that will like lay their eggs inside of aphids or whatever pest it is. They're quite there's quite often things like that. But you have to be able to support them, right? They're in their other life stages of their life, right? So like having the cover crops, the flowering plants that supports them. That's part of the cultural control, right? You have like an ecosystem and not just like a crop. So you have your rotating, right? You're doing your rotation. You have your cover crops, your flowering cover crops over here, your crops over here. You should be having a better balance than if you're just like relying on like bare soil, crop, spray, you'll have like these huge swings in pest populations. If you just rely on spray, it's pretty difficult to manage. Yeah. So like using those natural enemies is very important. And Max also mentioned like on the mainland, that you can buy ladybugs, right? Maybe it may not be the most effective thing because they'll fly wherever they want to fly anyway, but like, they come to eat aphids and stuff like that. That's why people buy them in the first place. There are natural enemies for basically everything. Okay, we finished. Okay. Now, I think you guys probably know at this point, you're a pretty smart crowd. I'm gonna test you a little bit anyways. On the left side, is this a fungal issue or an insect issue? Insect, what insect is it?
Mine?
On the left side, huh? Left side. White flies, huh?
Oh,
If it's a real bad infestation, they'll make this white stringy stuff. It kind of looks like mealybugs. It'll get like this too, yeah. This is a whitefly infestation. So if you're spraying a fungicide on this, probably not gonna help. How about on the right? Yeah, this one is mealybug. Good. Kind of similar situation, right? They make that white, waxy, gross stuff. Kind of looks like a fungus, right? And in fact, there is a fungus growing here too. The black sooty mold is growing on the honeydew, the sugar water doo-doo from the mealybug, right? So you have, I suppose you could call that a pest as well, right? You don't want like black mold all over your pomelo, right? But that's caused by the mealybug. It's not caused by the fungus being a pathogen. Okay. So managing ants will help that situation. Help, not solve, right? It depends on what your goals are. So we're gonna move away from like the pest and IPM sort of stuff and into the next section, which is like the most boring thing you can think of, like going back to middle school. But it is necessary to know if you're gonna use pesticides and use them correctly. The measuring things and math is essential for being able to apply pesticides correctly. So if all your other management methods fail your goals, right? Your goals that you set, like, oh, I use my cover crops to do my pruning, but I still have mealybugs. And they're like, no one's buying my fruit because there's mealybugs on it. Okay, maybe now I need to spray or apply some pesticide, right? Now you need to be able to do some math. Okay, this is like the core math concept that you need to know is ratios, right? So like I'm starting on the bottom here. I think we can, you know what? Let me go to site sizes first because it'll be faster. Geometry also is important. So you can, like, if you're structural pest control, you're in 3 dimensions, right? You have to measure height, length, width, and then calculate your volume, right? You have to multiply together. If you're in agriculture, for the most part, you're doing 2 dimensions, right? So you're like multiplying your length and width for your rectangles, squares, or you're doing your stuff pi squared for your circles. The thing that I can't pronounce, theorem for triangles, and then you kind of add these little shapes together to get irregular shaped sites, because it's oftentimes your yard isn't a perfect square or something like that, right? You might be like, look like there's a little triangle on the edge of a square, so you add them both together. One other thing you can do is easy, but expensive, is GPS stuff. So if you can like take your 4 corners of your fields and then like you just go on QGIS, oh yeah, it's 2.7 acres. Or you can go to Google Earth and like poke around, oh yeah, this looks like the corner of my house, okay, and then I have my area here. But that's 2-dimensional, right? For structural, you're gonna have to calculate volume. So it's 3 dimensions, right? You're gonna have a cube for the house with a little triangle on top. You add them all together, right? I won't spend too much time on that because I think it's more like you can measure things with a measuring tape, or GPS will help you for a lot of that kind of stuff. But especially what you're gonna see a lot on the test that is challenging, I think, is the dilutions and ratios. Yeah. Everything you do is going to be a fraction, and you're going to be cross multiplying. Okay. The way I think through things myself is not like this, but this actually works for pretty much everything. And if you're gonna take the test, every single math question on the test has this in it. Okay. Just to like a little bit of background for fractions, if it's been a while since you've been in middle school, like for me, 1/2 is the same as 4/8, right? So you can simplify or reduce down your fractions to another fraction. But you're gonna start with different numbers. And we'll get into where those numbers come from in a second. But just remember that that's a thing, right? 8/16 is the same as 1/2. Okay. Then everything we do in pesticide calculations is we're gonna have one number we don't know and we have to find it. And they're all fractions. Okay. So you're gonna have 1/2 times n/8. So an example, I don't know why they use n instead of x. Maybe my teacher was different in middle school. And then you divide down. So right, you cross multiply. 1 times 8, 2 times n. You have 2n, right? 1 times 8. Divide down again, and you have 4. Okay. It's not super hard. It's just the same process every time, but it's knowing where those numbers come from and why you do it. Thinking through it is a little bit more complicated. So we'll go through a couple of examples to help frame our minds of where these numbers are coming from. So let's say you have a product, just whatever product it is, right? We don't have a specific example here. It says 2 ounces, you need a dilution of 2 ounces per 10 gallons of product. Okay? Let's just say. But you know your sprayer, you calculated your output, right? You've calibrated it for several products you like to use. You're doing 7 gallons an acre. Oh, sorry, 7 gallons to spray your field, not acre. My bad. Okay, so we know we need, the label says 2 ounces for 10 gallons, but you know your field is 7 gallons. If 2 ounces goes into 10 gallons of water, how many goes into 7? This is where those numbers come from, okay? So let's walk through the steps. Right? We set up our fractions, our ratios. So 2 ounces or 10 gallons. So that's how we get our first fraction, right? We know that all that information, right? Yeah. But we know we need to get ounces for 7 gallons because our output is 7 gallons. So we have our X up there, our unknown number. That's where that comes from, right? We need to know how many ounces to mix in our tank for 7 gallons to spray our field. So we do our cross multiplication thing.
Keep going.
Okay, yeah. We cross multiply. Whoa.
Yeah, there's a 0 missing from that one.
Okay, yeah.
Okay, people make mistakes.
Yes. We can go back to the math on, or the picture on this one. But anyways, we're gonna get 10 times x, because we're cross multiplying, right? And then 2 times 7. So we're gonna get 10x equals 14, right? And then to get rid of the 10, we divide by 10. So it's gonna be 14 divided by 10.
1.4.
1.4 ounces. Now you look back at it, right? Go back to the beginning, make sure that it looks right. 2 ounces for 10 gallons. We're gonna spray 7 gallons, so 1.4, does that look reasonable?
Yep.
Yeah, right, so like we're good. If you end up with something like 114, you probably divided wrong. So like, go back at the beginning and think back, does it make sense? Like, did I just reduce a little bit or did I increase by accident? Okay. We will remember to fix this slide later. Okay, now another scenario here. Okay. We have a label rate of 2 ounces per acre this time. It's not a dilution of product in the tank, it's per acre, right? You'll see both happen. Your field is 10,396 square feet because you have GPS equipment and you measured it. Or you have a very long measuring tape. Either one. Okay, 2 ounces of pesticide cover 1 acre of land. How many ounces of pesticide is gonna cover this 10,396 square feet? I'm thinking Max here now because he put the acre conversion here for us already, so we don't have to do more math to figure that out. Okay, we have 2 ounces for 43,560 square feet over what we want to find for our fields, 10,396 square feet, right? Then we cross multiply. Yay! See, like same process for everything. If you're gonna take the test, remember cross multiplication. Okay, you're gonna have one that you don't know, and the rest you know. Okay, and then we divide by. We want to get x alone, right? So we divide by 43560, and then we get 0.477 ounces to cover our field, or what it doesn't specifically say field, but whatever, lawn, whatever we want this time. Does this concept make sense to you guys on how to calculate this or area?
No.
Okay. Or sorry, the dilutions. This math is like always what you're doing. Every label, you're gonna have to do this kind of math. And you very rarely find something that's exactly as the label rate. So you're gonna have to do math. Now, like, think about your equipment, right? So we just did some math pertaining to the label and what we need to do. But how do you make your equipment do this, right? It's a different story between knowing what needs to get put out and then how to make your equipment do it. So first thing to do is calculate your area or volume, right? So we have like 3 different dimensions we can work in. We have the structural people that do fumigation, that's 3 dimensions, right? We have like landscape and farmers that do 2 dimensions. We have lawns and fields. Then we have the structural guys again that do linear feet around structures, right? 3 dimensions we could work in, but you gotta know what that site size is that you're working with. Okay. Now I assume that you already have equipment. If you don't have equipment and you find what product you want, make sure that equipment can be calibrated to give you the output that you want. So if you're gonna buy equipment for a product, buy the right equipment, check the output from the equipment. They'll have it on the equipment specs to what your label rate needs to be. If you already have equipment, which I assume most of you do, you're gonna have to determine your flow rate, right? So you probably already have it set for something, or you haven't calibrated in a while and you don't remember what it is. So you gotta find out, like, what is your swap? How long is your boom, right? Or if you don't have a boom, like how wide are you spraying with your 1 nozzle or whatever it is? Or if you're like doing a hand backpack sprayer and you're doing this thing, measure how wide you're spraying when you're doing it. That's your swap. Your flow rate is output per minute. So if you're working with like a fumigant, I guess it would be how much gas goes out in a minute. I don't know if that really matters to you or not. For like spray equipment, it matters a lot, especially like each nozzle needs to be same output. So you turn it on for a minute, you run it, you see how much comes out in a minute, right? If you have 6 nozzles, you'll add all 6 together, right? Okay.
Yes.
And then your tank capacity, like how much you need to mix at one time to get a certain amount of area. These are all things you need to know before you start. Okay. Then application speed really matters. So like if you're using a backpack sprayer, I'm a tall guy, Max is a bit shorter. I walk a lot faster than Max walks. So my application speed is faster than his, right? If you have a tractor, you put it in, like 2000 RPM in first gear. Well, it's not first gear, maybe like 3rd gear. And then 6th gear, you're gonna get different speeds, right? You're gonna get different outputs. Even though your RPM is the same, your pressure is the same, blah, 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 right? Your gear is different. So the example here is 3 miles an hour here is giving us 20 gallons per acre. But if you go 6 miles an hour, you're only getting 10 gallons an acre, right? So it's not just the output from the boom, it's also your speed of application too. Okay. So you know more now, right? You know about your equipment, you know about how you're gonna apply with your speed. And you know, like this is gonna change, right? Like if it's a little bit windier today, let's say it's 10 miles an hour, you wanna use larger droplets, you change out your nozzles, you're gonna have different output, right? So you're gonna check your flow rates, something like that, yeah? Even if it's the same product you've used before. Okay, where are we at? Determine product carrier rates. Okay, that's the math that we just did, right? We're gonna look through what the label says. Okay, I know what my equipment's at. I know what the label says I gotta do. Now, I gotta make a match. So, how am I gonna make it match? Change your nozzles, change your, I guess your pump pressure will change volume a little bit, but not too much. Your speed is gonna be your biggest thing that will change this. So like if you're using a tractor, it's a lot easier to control speed than it is on ATV or by walking, yeah? So you gotta get a metronome and make sure you're doing things at a consistent speed or else you're not getting your flow rate right and your speed right. So let's say like you end up with something like, oh, I want 20 gallons an acre, but I'm only laying down 10 right now. My label says I need double. Then you half the speed, right? You go down a couple gears in your tractor, you make your speed half to get up there. Not all equipment can be adjusted to every single thing that you want and every product that will work, right? So you might need different equipment for certain products. Make sure that your equipment works for your product at the correct rate before you use it. Make sure to calibrate. So if you're using like liquid sprays, you can use water most of the time, right? To calibrate your equipment, okay? Like I'm gonna go, okay, like I know that I'm gonna do like 1 minute driving my tractor. I'm gonna see how far I go, right? My distance, my swath, I know what my area is. And then I'm gonna time 1 minute for my flow rate, see my output. You can do all that with water, it's fairly safe, right? And then you can adjust your speed or your nozzle from there. But for granulars and things like that, if you're spreading like fertilizers or granular herbicides, insecticides, that sort of stuff, it's a bit different, like because all products will have a different size of granule. So if you're using like, we like to use in our demonstrations, kitty litter, right? The size of the kitty litter is gonna be different than if you're using marathon insecticide, right? It's gonna be a lot smaller. So you can't use a mock product to do your calibration. You'll have to use a real product and make sure it doesn't get like lost, right? You put it in a tarp and do it. Same concept, you figure out what your swath is with a very big tarp, okay? With that product in your spreader, how wide does it spread? Okay, my swath is 10 feet, cool. How much is my output in 1 minute? How far do I drive in 1 minute? Then you know what you're laying down per acre and stuff. Important point here, knowing your equipment parameters or what your current output is not the same as calibrating. So knowing what your current output is the beginning of your calibration. It's not the end. You know your output. You know what the label says that you have to output for this product. And then you change something to get to that level or to that number, okay? Usually what you'll change is your nozzle or your speed. Yeah. Is there any questions about this? Okay, cool. It's kind of a complicated thing. Every piece of equipment is different. So like it's not easy to talk through all of it without actually having equipment in front of you. Just to make the point, there's a lot of different equipment types here, right, that you could use for your job. Dry applications, right? There's dusters, There's like all kinds of weird stuff too for animals, like chicken dusters and stuff. Yeah, there's a lot of different stuff. Granule applicators, there's spreaders, there's drills. So like if you're planting a row crop, like corn or something like that, you can have an insecticide box behind your row planter, right? It follows you. Shank soil injectors. Good example that Max and I love is Tilone. Ram air injectors. Ram. No, this one is not a injector. Yeah, it's a disperser. Yeah, I believe. I've never used one, but that's the thing. Gas applications. There's pressure fed, gravity flow. I think for Vicane, it's gravity, right? You weigh on a scale.
Yeah.
Yeah. Okay. For liquid applications, there's a ton of different things. There's aerosol things, there's foggers. So those things that look like a leaf blower, people go up into orchard trees, you know, like get rid of their white flies. It's a mist, like an aerosol. It creates an aerosol. Very helpful in those environments, but like very high risk for drift, right? The smaller the droplet size, the more potential it has to drift. Trigger pump, hose end, push pull, compressed air, bucket and or trombone, backpack sprayer, wheelbarrow sprayer, estate. I don't even know what that is, but it's a thing. Power driven boom sprayers is thing that I'm most familiar with myself. Boomless sprayers is like one nozzle on the back of an ATV. If you're like trying to clear a trail, right? You want to like make sure that the bushes and vines aren't coming into the trail. Kind of drive an ATV and it sprays one nozzle. Air blast. This is another thing for orchards. It like has a fan that sprays up into like the canopies of the trees. Ultra low volume. This is like aircraft thing, like very low volume sprays over huge areas. Controlled droplet and electrostatic. There's a lot of different application equipment. This is why it's like we can't really explain in detail in a class without actual equipment in front of us. But the concepts are the same, right? You need to understand your output and your speed that you're going, etc. Okay. There are, Max was kind enough to include some pictures of specialized equipment too, which is kind of cool. And then there's some things you might see here. There's recirculating sprayers, shielded applications. There's a photo on the next page of this. I've never used it, but it seems helpful in certain situations. Wiper applicators, rope and wick. This is like if you, let's just say, right, you have a lawn, but you have this guinea grass problem, right? But any product you use, you just spray it on, will kill both your lawn and the guinea grass. This is like something you would use, set it at a certain height, wait till the guinea grass grows above your lawn height, and then just roll it onto like it touches whatever's taller than everything else. Super hard to calibrate and do that like your correct rates for that, but it's a thing that you can use. Chemigation, there's a photo of this on here too. It's extremely effective for certain applications, systemic insecticides, but it's specialized, it's got its own category, stuff like that. You'll see a picture on the next slide. I think next slide, yeah. And then bait stations, this is for like rats. Yeah, you have a bait station, there's different kinds, there's like the ones that shoot a pin through its skull, there's the poison bait, there's the electric,
Rats.
electrocuted one thing, yeah, for rats. Yeah, exactly. And bait applicators, these are things like spreading snail bait, stuff like that. Okay, this is a shielded application. So this is kind of an interesting concept here. Like if you're going to use glyphosate or something like that, but your crop is sensitive to glyphosate, but that's the only product you have, or you're going through your resistance management program and you want to change up your mode of action, you can use this. It will spray only in the furrow, not on your plants, right? Not on your crop, excuse me. Kind of cool. I've never actually seen that, but it looks like it would work.
Shouldn't that guy be wearing a respirator?
Depends. It depends on the product. A lot of them don't require respirators. Yeah. Depends on the product.
Probably no matter what.
Legally speaking, it's the employer's responsibility to provide whatever PPE is listed on the label. If you want more as an employee, you legally, like, the employer doesn't need to buy it, right? You could buy it yourself if you wanted to, but anyway, sort of another thing. This is an example of a wick application. So like a wiper, sorry, like you fill the tube with whatever product at whatever dilution. Then you have this like cloth thing that it soaks into. Most times this works best on like an ATV or a tractor. You have some hydraulic thing, you lift it up 8 inches, because that's how you want it. And it just touches whatever it touches. Kind of a niche thing, really hard to calculate rates on this, so be careful if you use them. And then these are dosatrons. So these are dosing pumps. They're volumetric pumps. You can see this is one water line going through here, right? And then you have each pump giving a volume per volume amount of whatever is going through that pipe. So if you set it to like 1 to 10, for example, you'll get 10 gallons of water and 1 gallon of product. But you can change whatever that is on there. So this one has 1, 2, 3, 4, 5 products, probably fertilizer. So you start with the acid to make sure things mix, then you pour your base, depending on whatever your water issue is. And then your different fertilizers. But you can also do this with imidacloprid, for example, running through the system. It's a systemic, right? So it goes in the soil, the plant soaks it up, and it works for a long time. All right, so for spray equipment components, well, I guess this is okay. For sprayers, there's different types of pumps. I wish I had some examples here. Dr. DeFrank has some pretty cool ones that he like cut open so you can see the inside and how it actually works. But there's roller pumps, gear pumps, centrifugal pumps, so it pushes everything to the outside and shoots it out. Diaphragm, so it's like using suction to make it happen, and then piston, which is like it's like an engine, basically, how it works. Yeah. Agitators. So like some products, a lot of water soluble, or it's not water soluble, wettable powders and flowables, for example. Also some like emulsifiable concentrates, you want to keep them mixed, right? There's mechanical agitators, so it'd be like a big paddle inside of your tank, or a small paddle if you have a small tank, right? There's a bypass agitator. These are kind of cool because they help you regulate your pressure also if you have, so like the way it works is you have your pipe going out, your pump, and then you have a line that comes back into the tank and it recirculates like that. So if your pressure is too much in your pipe, it's just going to push more back into the tank. It's kind of cool. There's hydraulic jet action agitators. Yeah, it depends on what equipment type you have. You're gonna have different ones of these, right? But just know, like an agitator, the point is to keep things mixed so nothing settles out. Yeah, you're gonna have different kinds of mixers. Yeah, okay, gauges and valves. You're gonna need pressure gauges at several places. To make sure you're operating within the PSI that works for your nozzles, and that your pump can not die in, and your pipe's not going to break, and blah 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 blah. Pressure regulators. So this is like a release valve that would shoot back in the bypass. Okay, like when you reach max pressure, now it's going to open this valve and then release back into the tank. Throttling valves. This is like on and off. Like yeah. The spring-loaded bypass valves, this is the same thing. Once it reaches a certain pressure, it's gonna shoot back into the tank. Unloader valves, this is when you're done. Like when there's no more pressure, then it like drops out. Filters, there's different kinds of filters you can have in spray systems. There's tank screens. I wish I had examples here. I could next time. Like in a backpack sprayer, there's that little like plastic thing that's on top. Make sure that it's no big particles or like dirt or whatever, rocks going in there. But also like on your boom, like right before your nozzle, you're gonna have like a little mesh filter, and then make sure whatever mesh filter you use works with that product. Because if you're using 100 mesh and it only says up to 50 mesh, you're gonna block your system, right? Then you're gonna have to clean everything out, and it's gonna suck. Tanks. There's different types of tanks. There's plastic and metal. Be cautious, right? I know, for example, right? I believe I have to say this. Any product mentioned here is for educational purposes only, and there's not an endorsement nor discouragement of use of this product. For example, Honcho on the label, it says don't use with galvanized steel because it will create toxic gas, right? Okay, I'll use a plastic tank. Make sure you read the label. Nozzle types. There's regular flat fan, so it's gonna be like it shoots at a triangle kind of angle, more dense in the middle. It's like an egg-shaped kind of thing, more dense in the middle and less on the outsides, and then you usually have an overlap, right? So you're lifting them up, so you have like a 10-20% overlap depending on what your nozzles you have. There's even flat fans. These are usually for like if you want to spray just the furrow, like you have that shielded applicator. You don't want it to spray off to the side. You don't want it dripping. You just want it here between my rows of crop, right? I'm not on my crop, but like I want that herbicide in the middle. You would use an even fan, so it has the same volume for every part of the distribution of the spray. It's only right here. Flooding nozzles, side entry, hollow cone nozzles, core insert, disc core, adjustable nozzles. Adjustable nozzles are like those things that you have on your backpack sprayer where you can like go from a stream to a fine stream, then to a full cone, then to a hollow cone. Anyway, they're all used for different things, different reasons, right? Yeah, nozzle materials, you can have brass. It's very common. It does react with water, so like be conscious of that. Not as bad as other things, but it does, you know, it turns green and stuff. Also, if you're using any flowables, wettable powders, or anything abrasive, brass is not a good choice because it'll wear out the hole, and then like through your spray, you'll start getting your shape incorrect, and then your volume is more and your droplet size will be bigger. So it'll change over the duration of your spray. Don't use brass or plastic if you have something abrasive that you're spraying, okay? Yeah, stainless steel is better for abrasive stuff, but can be reactive to certain chemicals. Aluminum also is not great. It can be, well, I shouldn't say not great. Everything is used for different products in different situations, right? Aluminum, yeah, it wears through very easily, similar like brass. So be careful. Tungsten carbide is super hard, so it's great for those things that are abrasive. It's not gonna like change your nozzle hole too much, but it's super expensive. And then there's ceramic, right? So like ceramic, usually it'll be plastic on the outside, and you'll see this little white stuff on the inside. That white stuff is ceramic, great for abrasive things, not expensive. Okay, so like if you're gonna spray a flowable, like ceramic or tungsten carbide, probably ceramic. This is cheaper. Okay. Also, ceramic is non-reactive to most things, so it's a good choice for a lot of applications. I guess I can give a plug for our class. Come to our class. We have equipment. It does cost money because we have to buy equipment and like all of these nozzles and stuff, but you'll get to play with them, you'll get to see them, you get to use them, you get to understand like what they are, how they're used, and why. Yeah, okay. And this is our contact info. So again, Max is with now it's called DAB for some reason. It used to be Hawaii Department of Agriculture Pesticides Branch. Is currently Department of Agriculture and Biosecurity. So they changed the acronym, just be aware of that. I am an extension agent at UH, and I also work directly with the Pesticides Branch because I am the state's PSET, the Pesticide Safety Education Coordinator. I think that's all for me. You want to close?
Yeah. So like Mark said, here's our contact information. Reach out to us when you need. We really appreciate you all coming in today to engage with us for this workshop. If you guys have any questions, we're going to stick around in the room so we can talk story afterwards. But for you certified applicators, make sure that you sign out going out to the door. If you don't sign out, then you can't get credit. If you're not a certified applicator, you don't need to worry about signing out. That doesn't matter. But thank you all very much for coming. We really, really appreciate it. So yeah.
Thank you.